Welcome back here to the channel Tapa-olho Azul and Super Acadêmico, and today I'm going to talk about something that I don't know anything. I just finished reading, here reading this book, The Theory of Everything by Hawking, and I will challenge myself to give to you some kind of comments about this book, but with the help of the man himself. I mean, his avatar on the AI app that I downloaded called Character AI. I will ask questions about what he said in the book and comment some things that I did understand. Before I begin, don't forget to subscribe to the channel, give the like. That's the man, Stephen Hawking, the late Stephen Hawking. Don't forget to subscribe to the channel, give the like, comments, and share the video, and help the channel wherever you can, watching over and over again the playlists and all the contents that we have here in both channels. So let's begin our contents. So here we go, talking about this brilliant book of Stephen Hawking, by Stephen Hawking, The Theory of Everything. He talks about, there are 6 or 7 lectures that he develops to explain, like, first the history of the cosmology, about the universe, talking from the Bible, the Holy Scriptures, to his theory, passing through Einstein and Isaac Newton, etc. And then he goes into the problem of trying to coexist the theory of universal gravitation and the theory of the quantum mechanics. That the problem is that the the way that the universe functions in the large scale doesn't match with the particles. So for me, that's I'm not a physicist. I'm a social scientist. It's very strange, this kind of developments and this kind of theoretical development, because I mostly don't understand the mathematics of the thing. I just pass me over the head. But I tried to understand by the way he writes, that he wrote, and the better possible I will transmit to you, comment to you, with the help of the AI that emulates his sayings. So I think the first question that I'll make here to the AI is about why study the origins of the universe, and why this reflects to us today. So let's first see how I'll do that, how I'll develop this question. How studying the universe and its origins is important for us today? Well, I got really frustrated now because I was trying to connect with the AI app and it didn't work. It just didn't work. I access, I logged in, I sign up, I did everything that they said, but it didn't work. I just given up to use AI to develop these comments about the theory of everything by Stephen Hawking, but I will not give up of commenting. Okay, even I am not a physicist, I'm not a specialist on this. I'm just a curious, like everyone else, I think. Well, as I remember, the first thing that he presents in the book is this history of the cosmologies. the studies, the theories about how the universe is created, constructed, developed, whatever. And well, first of all, of course, he discharges in a way a theory about a creation, conscience, conscious uh, creation about of the universe by a being, an intelligent being. For me, of course, it doesn't make sense that think that the universe is some kind of a intelligent creation, because I don't see the order that many people see in the universe. But okay. And he speaks about how developed from Aristotle to Copernicus to Galileo to Newton to Einstein and to himself and his contemporaries. Okay. Well, the great problem that he presents in the book is how to explain the complexity of human life, the complexity of the life as we know today, with so many things that are different, in a way that are not the particles that that we are all made of. And the particles are identical in a way, as electrons, protons, neutrons, and the smaller particles, quarks and whatever, that I don't understand. But I think the great problem that these physicists, these theoretical physicists face is how to deal with this complexity of life, since supposedly everything started with these particles. And then he describes the way that developed the general theory of relativity by Albert Einstein, which shows that time and space are dimensions that are interconnected. And since this connection of time and space has a way to affect and be affected by gravity, and how this works in the large scale of the universe, made a huge problem in the way we think. When we think in the universe being like Aristotle thought, the Earth, and the Earth being circled by the other bodies in the space, we tend to see some kind of a order that makes some sense, but there are discrepancies in the movements. So when the science developed to the modernity, with the development of a telescope, with the observations that some bodies move in a way that shouldn't, the way that it wasn't supposed to move, then these questions began to get more and more frequently. And when Einstein came with this idea of bending of time and space because of gravity, everything became very much more complicated for the physicists, since the religious beliefs were like left behind, because it wasn't more acceptable. We could not accept anymore this kind of explanation about the universe. So the disputes is merely theoretical, with not putting anybody to the bonfire of the other religious beliefs, like in the Inquisition in the Middle Ages. So we, as people, as science people, as people that make questions, go after answers in a rational and possible way. I I I I, I could see, I could realize that many of the formulations came that came from Stephen Hawking and other physicists are very much creative thoughts. They think in a way very creatively with the help of mathematics, and they develop this kind of a image of the universe. And I thought was very interesting hearing the book, and as far as I could understand, they see the universe with a collection of bodies, huge bodies, planets, stars, galaxies, and uh, what's the other thing? Uh, nebulas, and mainly the problem with the black holes. So he has 2 or 3 lectures about black holes that are very interesting because, as I could understand, the observation, the study, the calculations about black holes makes possible to understand how the fabric, how the whatever the universe is made of, how it may work, and how it may have worked in the beginning of the universe, in its origins, with the Big Bang. And he has in the lectures a very important saying about the Big Bang, because the echoes of the Big Bang are still possible to be to be heard today, with the discovery of the 2 other scientists that won the Nobel Prize, that detected that in every direction that you point out the antenna that they were seeking microwaves, they discovered that this background background sound of the universe, of the formation of the universe. So they developed this idea that if the galaxies are getting farther, uh, more distant from Earth, from our view of the Earth, in every direction that you look, probably in some when and some other time in the past, the universe was very small and began to expand. And this expansion is also studied in a very complicated way, because they don't know how a dense a being, no, not a being, a particle, a mass so dense that began to develop heat in a way that expands very rapidly, and then began to cool and expand more slowly, more slow. And this explanation helps to understand why the universe seems to be expanding the way it's, if it's expanding now, if you look backwards, it would be contracting. It's the way they developed the theory of the Big Bang and the expansion of the universe, but it doesn't solve the problem of the particles, because the particles work in a different way. And this is the intention of the book, in a humble way, I think, to solve this problem. A theory of everything, because it's a theory that deals with the very large scale of the universe, and in according to the very small dimensions of the particles, and how that can be understood by a layperson, but anybody like me. I heard the book, I try to understand, and try to pass on to you in a very simple way, just because I'm curious about that. And the conclusions that Stephen Hawking got to in the end of the book is very touching, very emotional, because he says until the 19th century, kind of middle 19th century, the philosophers, people like me, that think of the whole of the life, used to understand astronomy, understand physics in a not so complex way that people like me could comment and develop theories about these things. But since the sciences began to get apart, to get more specific, and physics is one of them, and get so complex and so particular that most of the people don't understand what the other science are doing, especially something like that. And he says that his hope is that eventually, with a theory that more close to the truth, attends to to explain the universe, the history of the universe, the origin, the limits, the boundaries, the infinity of everything that seems so complicated to a lay person, is possible to be understood by a lay person in a way like today. He mentions that, like today, it's very common someone use the relativity, the general theory of relativity by Albert Einstein, to explain some things in the common life, in everyday life. And he hopes that if a theory about the universe that unifies these fields of the physics, of theoretical physics, if are able, if something like that is able to unify the thought about the universe, then the layperson, and someone that's common, that's a regular person, can understand minimally the basis of that, so it will be possible to talk about that in a more understandable way. It's so not so esoteric in a way that seems something of science fiction. Okay, I think that's why I'm able to. There's something that I really enjoy when Stephen Hawking says that about how he explains his vision of the universe as being finite, but not with an end. That's strange to hear, but he says, just like the way the planet Earth surface works, the planets, it's finite. It's not eternal. It's not infinite. It's not infinite. I don't know how this word. So the planet Earth, when you you walk around the earth, you never reach the boundary, never reach the ends of the earth because it's rounded. And since it's rounded, you can never find its ends, but it's finite. So he says that the universe probably is something like that. If you go straight in a hypothetical spaceship, you go straight ahead through all the universe, you just reach the same point because it's finite, but it's not, doesn't have a boundary, doesn't have an end. It's a weird way to put it, but I understood this way, and I think that's why that movie Interstellar, it's seems so accurate about this, because when the travelers go to the wormhole, the wormhole is not something stretchy. It's a circle. It's a sphere you go into, but you actually just turning, turning infinitely to the same point. So in a way, the the part when the character goes to the into the black hole. By the way, this is Stephen Hawking says this is impossible. If someone go into the black hole, for the person that goes to the black hole, it's never going to reach anywhere because the gravity is so strong. And for someone that's outside and watch someone going to the black hole, just the person will become thinner and thinner and thinner and thinner because of the gravity, but it would never disappear. It's crazy. It's a crazy thing to think about. But as mathematically makes sense, I think. Well, probably. I don't know. I don't understand this mathematically. This math. I don't understand this math. I try to understand in a conceptual, visual way to myself, and I hope to you too, eh, the audience of these channels. And so, back into the movie, Interstellar, the character, when he goes into the black hole, he encounters the ship that is coming, because actually is a rounded place. It's a fictional way to show that something that seems finite actually in, doesn't, that seems aligned, seems to be aligned, actually is not aligned. It's like a way to think about dimensions, and since we have three dimensions, we don't think ourselves in another dimension like the time. We don't see ourselves in on a fourth dimension. In the same way that something, some fictitious thing that is in the two-dimension world would not understand a third dimension. So it's like when a line is looking to other line, it doesn't see the other line as a whole, for example, as a whole. And that's the way the universe would be like. If you just go, it doesn't end. But in the same way, you don't find the boundary. There's no place where it ends, but it goes around. It goes around. Well, I like that analogy with the planet Earth. It's what easy for me to understand. I hope I could pass on to you minimally. I hope expect that. Well, I'm going to stay in this place today. I think I was a little frustrated that the AI couldn't help me to make this video more interesting for you, but I hope I at least make you wonder if you want to read or hear this book. I recommend the hearing. It's a very nice hearing. Very the actor that make the narration as Michael York is a very nice voice. It was very entertaining for me too. So that's it for today. I hope you enjoy, and see you the next video. Bye bye. Don't forget to subscribe to both channels.